Thank you very much for joining this Great Smart City Institute. We have a seminar series for those who do not know yet. We regularly invite speakers from both on this campus as well as outside this campus to talk about a smart city kind of development. And today we are very pleased to have Mr. Kelvin Li joining us. He is the Director of Strategy and Business Development at Schneider Electric, formulating corporate strategies to drive business growth by leveraging innovative technologies in the energy industry. He has over 20 years of experience in power utility, energy consultancy, and energy corporations in Hong Kong, Singapore, the Netherlands, and UK. He has 3 master's degrees, one from Harvard, one from London School of Business, and one from the University of Hong Kong. He is also elected to the Prince of Wales Business and Sustainability Program by the University of Cambridge. His talk today will be Sustainability in Action, moving towards the buildings of the future. With that, I welcome Kelvin to this seminar series. Thank you.
Okay, thank you very much, Professor Hong, and also Vivian for organizing this webinar, and very glad to see you all here. Although you can see me, I can just see some of your photos and name, and very good. But actually, let me try to share my screen, and then I will start my presentation. Okay, okay, this one. Okay, can see my screen? Yeah, try to track this. Yeah, okay, right. Okay, very good. So I will start now. And then, so today's agenda, first of all, I would like to introduce our company, Schneider Electric. Some of you know, some of you are very familiar with Schneider Electric. Some of you are actually not. And so I would like to introduce around 5 minutes, I think. And then we talk about the evolution of buildings, the history, a brief history of buildings. Okay, we talk about the history. Then I will talk about the future. What should be our buildings? We call it buildings of the future. Actually, there are different names. Some of you may call it living buildings. Yeah. And so what are the requirements of a living buildings or buildings of the future? Then I'll also talk about this. And lastly, we'll talk about the cloud-based and IoT-enabled analytics. Why? Because digitization is a very key to facilitate the innovation and digitization of the buildings and bring in the buildings of the future. And that's why I would like to talk or spend some time and to talk about those kind of analytics. We call it digitization. So that's the agenda. And I guess I'll spend around 50 to 60 minutes on all those slides. And afterwards, then can open to all of you for the Q&A. And just feel free to ask any questions in the Q&A section. I will try my best to answer yours. Yeah. And this is just a very brief background about myself. And actually, Professor Hong already talked about my career history and also education. And I have 21 years of experience in the energy industry. I graduated from Hong Kong U, Electrical and Electronic Engineering in year 2000, so already 21 years. And after I graduated, I joined CLP Power, and I spent my first 11 careers in CLP Power. Then I made the decision to do an MBA at London Business School. Why I go to London? Because I couldn't join UST. That's why I have to go to London, have no choice. And then afterwards, I could spend in London, my 2 years in London, and work as a big consultant, full-time partners. And afterwards, I made another bold move to Boston to get my MPA, Master in Public Administration at Harvard University. After 5 years overseas, and came back to Hong Kong, and in the past 5 years, I worked over 3 companies, and just 2 years ago, I came to Schneider Electric. Yeah, so that's a very brief background about myself. So now we talk about, after I talk about myself, then I'll talk about Schneider Electric. And some of you have already known, some of you not really know anything about Schneider Electric, and most of you will, if I ask, do you know Schneider Electric? Then people say, yes, I know. Oh, how do you know Schneider Electric? Yes, I go to the shopping malls and I could see a lot of elevators bearing your name. Oh, so sorry, this is not Schneider Electric. We don't make lift. Okay, at this time, we don't make lift. We don't make any elevators. What you could see is just another company of the, it's a European company, but it's not Schneider Electric. Try to notice the spelling, then you can figure out the difference. So back to Schneider Electric, and you can see the map here, right? So you can see this is the revenue breakdown by our regions. Asia Pacific and North America is the major revenue contributors in our company. So Asia Pacific is really a very important market to us, especially in China and the Southeast Asia, and the economy is growing. And then Western Europe, 26%. One thing is Schneider Electric, our headquarters, where is it? A lot of people say Germany. Oh, no, this is not Germany, although the company name sounds like a German. Yes, it's a Jewish surname. That's why a lot of people will think it's a German company. Not really. We are a French company. Our headquarters is in Paris. Yeah. And right now, although very traditionally, our company drove significant proportion of revenue from Western Europe because of France and Germany and the UK, but right now the other markets are growing, especially in Asia Pacific, and that's why we have our CEO and many executives residing in Hong Kong. And right now, actually, my CEO is just next door. Okay, I'm in a meeting room, and my CEO is just next door. Okay, yeah. So he's a French guy, a global group CEO. Yeah, and as you can see, he moved here around 8 years ago, and you could see the importance of the Asia Pacific markets and China markets to the growth of the whole company. Yeah. Just walk through some data about our company. Our revenue in 2019 is around 27 billion euros. Okay, if you take it, try to give you a number, convert it to Hong Kong dollars, it's around, then just simply times 10 is 270 billion Hong Kong dollars, and that's our revenue. We are one of the global 500 companies. And how about our employees? My employees around the world is nearly 140,000 people around the world. So the last figure I would like to give you is the revenue contributed to or spent on the R&D is 5%. Because 5% our revenue goes to R&D. Okay, and this proportion is increasing. You would say 5% is very small, but not really. If you're talking about the profit, so company, I will some companies, if their margin is not very high, just less than 10%. If some companies, the margin is higher, 30 or 40%. So we can see that actually, if this is 5% of the revenue, it is quite a big proportion of the profit actually. So you could see a lot of tech companies, they also spend a large proportion of their profit on R&D, and that's the way to keep the company grow. Okay, especially in technology companies. Okay, yeah. So how many years? We have 185 years. We set up in France at that time. It's not called Schneider Electric. Okay, because there's no electricity at that time. Okay, and Europe is a Napoleon time around that time, and lots of wars in Europe. So this company actually founded by two brothers, and they make the weapons. Okay, the cannon, something like this. But throughout the past 185 years, our company has already gone through 4 phases of transformation. Okay, the first thing is when electricity was invented, then gradually they changed from a steel company to power and control, and by acquisition, a lot of acquisitions in the past to facilitate, underpin this kind of transformation. And if you know, and some of you maybe are studying at UST Business School, and Harvard already written a case, back in my time, and even 10 years in London where I was, and they had a case study about Schneider Electric, especially on this kind of M&A, inorganic growth. We acquired a lot of companies for transformation and also for the inorganic growth. So this is a very typical inorganic growth model, actually. Yeah, so the power and control, and lots of more experienced people in the energy industry, they would say, oh yeah, I know that Schneider Electric. Yeah, I know it's not a German company. I know it's not an elevator company, but I know it's an electrical equipment company. Yes, it's right. Back in 50 years ago, still an electrical equipment company. But over the say the past 20 years, we shift our focus from power to energy management and automation. Okay, so no longer on the hardware side, not the equipment supplier, but more on the software. Okay, how you develop the software to facilitate our clients on energy management and then automation. Okay, and then in the past 10 years, we made another transformation from software to digital. So what we call the digital, okay, analytics, IoT, especially in the past few years, we have a lot of buzzwords, digitization, IoT, AI, whatever you like. Yeah, cryptocurrency, a lot of very fancy words, okay? And everybody, every company would like to tap into this kind of transformation to deliver the growth for the companies, yes, including Schneider Electric and also technology companies. So we acquired quite a lot of startups in the digital and also software companies. And especially in the past 1 year, 2020, although the economy is not very good, but we acquired quite a lot of software companies to facilitate this kind of digital transformation. Yeah, and that's why in later part of this webinar, I would talk about our analytics. Yeah, okay. And now about Schneider Hong Kong, and give you some, I've already given you some numbers, information just 5 minutes ago. So our CEO is sitting here, okay? And also some ExCom members, executive committee members, okay, 6 of them. They came from different parts of the world. Some of them, of course, came from France and then the UK and US, and yeah, they came to Hong Kong and to grow the markets in this Asia Pacific. And how many years in Hong Kong? 50 years. I think our company, okay, if we talk about Schneider Electric Hong Kong, then of course we'll be older than 95% of our people here, okay? At least including myself, I'm not 50 years old yet, although I know I'm old, okay, you would say so. And how many people in Hong Kong? Then around 400, if we include both offices, like a Hong Kong office. So I'm from the local office, Hong Kong office, but at the same time, we have global office. So they have around 150 people. So in total is 400 people in Hong Kong. And then we have also a JB around 300 people, and it's in Sha Tin, okay? I don't go through the details of our customer base, but just would like to know we have a lot of number ones in Hong Kong in terms of the customer base. For example, our power equipment, our LV equipments, and low voltage LVs. Yeah, it's not the French brand name. Yeah, very big one. Okay, so if you talk about the convenience stores, there must be some or at least one convenience store near your place, right? Okay, yeah, but for us, Schneider Electric, I can guarantee one thing, that at any building, you can find at least one piece of our product, no matter which is a transformer, circuit breakers, or some smart home solutions. You will find at least one. So we can guarantee this, exactly. Yeah, although you may not notice our name because our name will not be printed on the floor on the escalator, but we are hidden in some places, maybe behind the wall, yeah, maybe in some room that you cannot access. But if you go there, okay, you can find our name here, maybe in different brand names actually. Yeah, that's why you can't recognize it very much. And yeah, those are the projects we have done before. Purposely hide the customer names because of the confidentiality. But okay, you can see. Okay, although I didn't mention the name of our customers, but you can see, okay, our customers are, one of the biggest airports in Hong Kong. So you see, okay, understand what I mean, right? Yeah. Okay, so go to the topic of sustainability and digitization. So that's the core, yeah. And talk about the future. 2 things, 2 mega trends that we could see is the first one is efficiency, yeah. And you can see energy efficiency in 2050. We expect it will grow by 1.5 times of the existing one. But at the same time, carbon, because of sustainability, emission reduction targets, especially after the Paris Agreement, so we need to halve our carbon emissions. Then I'll give you the first graph, is energy consumption, the growth. You can see, compare our energy consumption back in 2018, and then we expect 2050 is around 50% growth, okay, just within the next 30 years, right? Yeah, and one thing is very good, and I like this graph, is you can see the renewable proportion in 2018 is just 15%, and then 30 years later, it will increase to nearly 15 to 30%. So renewables represent the largest growth in terms of the energy consumption, and it will nearly match petroleum and other liquids. Yeah, it will be the second largest energy or fuel if you like this term, the field in the world just after petroleum and other oil liquids. Okay, it will surpass coal, gas, and other fuel types. So talk about the carbon, then I'll show you another graph. Some of you are very familiar with if you are in the environmental engineering, environmental science, this kind of field. Then this one is about our pathways, the carbon pathways, and it's shown in Paris Agreement back in 5 or 6 years ago already. And what I like to say, we are now here, right? And then our Paris Agreement is set a pathway. We need to limit our temperature increase within 2 degrees Celsius. So this is this path, okay? This is path, this path. Okay, we need to do so, but try our best effort to limit our increase within 1.5 degrees Celsius with a lower path. So I just take the easier path, okay, 2 degrees Celsius path by 2015. Our carbon reduction, as you can eyeball this graph, is around half of the emissions right now here. That means carbon emissions, we have to halve in the next 30 years, right? So it also means that, okay, our by some just very simple mathematics and no rocket science here, okay, we can just simply say then the average intensity of our building is we need to decrease from 150 kilowatts per meter square per year in 2019 to 50, because you need to divide it by 3 times, right? So 50. That means that our efficiency must increase, especially our building stockpile will increase. It's a very big challenge to all mankind on the earth. Okay, this is the first thing, sustainability and efficiency we need to handle. And the next thing is digitization. I have already talked about or said the words more than 10 times just over the last 10 minutes. Okay, if you talk about technologies, then 3 things. I just mentioned 3 things. There are lots of technologies, of course, in the past 10 years. The first one is AI. A lot of people talk about AI. We can see a growth will be 6 times according to the International Data Corporation. So we have some research teams to help us gather the data from different sources, and we can expect there will be 6 times growth. Okay, between 4 or 5 years. Okay, from 2017 to 2022, 6 times growth is tremendous. Then how about the big data? 5 times growth. Okay, from 2018 to 2025, and you could see all the growth. We are not talking about 10%, 20%, or 30% double-digit growth. We're talking about times in the IT world. How about IoT? Sorry, and we could see the number of apps. Okay, 5G-based apps will increase by 35%, and IoT, Internet of Things, is the core technology our analytics will be based on. So you could see we mentioned in these 2 graphs, the first one is energy efficiency, the second one is digitization. Then we combine together, then we form this one. This is a platform, we call it EcoStruxure in our company. And if you come from the computer engineering or computer science background, you will see more or less the same framework. Okay, it's more like a textbook framework. Okay, yeah. So if you are not from the engineering field, would like to introduce this framework. Although we make it as a business, but the theory, the fundamentals behind are still the from textbook. And I will introduce this framework from bottom up. Is the lowest layer is the connected products. We call it hardware. So we are traditionally a hardware company. In the past 100 years, we manufactured power equipment, transformers, circuit breakers, and switches, and lots of bus bars, of course, very famous bus bars. Okay, yeah, don't forget to mention bus bars. So they are all the connected products. So why we said it's connected? What connected? In the sense that we have already installed a lot of sensors on our products. For example, in the circuit breakers, we have installed our sensors on monitoring, of course, its current, voltage, and also the temperature and lots of things. And those gadgets, they will transmit data to the upper layer. So we'll call it edge control. Edge comes from the word edge computing. Okay, so we call it software, for example, BMS. They receive the and data from the lower layer, from the hardware, from the sensors. So they'll gather together, and then they will plot some graphs, and for the people like the facility managers to monitor the, for example, the energy consumption or the operation of the hardware. Okay, so we call this one edge control is the software. Okay, software has existed in the world for 40 or 50 years already, now with the developments of computers. And then right now we're talking about digital transformation. Then we need to add one more layer, is the digital layer. You would say digital is part of software, right? Yeah, digital is part of software. At the same time, it has more meanings. For example, the leverage of the IoT, of the AI, of a lot of advanced digital technologies. For what? For analytics. Okay, so not just to monitor the data. So we collect the data. At the same time, we need to draw out some insights from those data. And that's the thing we need to do, not just monitoring. They can give you some insights for you to make strategic decisions, and that's very important. And right now, our business is more on this side. Okay, and as you can see before, as I said, like transformation is from hardware to software and then to digital. Okay, yeah. So that's the three things that you need to remember, no matter it's a textbook theories or you're going into the IT or OT field, okay? And you can see the four domains here, the four big segments in our company, like the buildings, especially in Hong Kong. Hong Kong is famous for the buildings. We have a lot of high-rise buildings, skyscrapers. Yeah, okay, buildings. Actually, the holds the lion's share in our company's revenue. And the next one is data center. Data center is also very important, especially in Hong Kong, in Sheung Kwan, or the next area is Kwai Chung. Okay, data centers. And this one industry is around 20 years ago, we've already moved a lot of industrial plants and manufacturing plants to China. Then industry is not a big one. Infrastructure is also big, including the airports and also the trains and subways in Hong Kong, and also the highways and tunnels. So we count it as infrastructure. So for these four big domains in every market around the world, it will cover at least, I think, at least 80% of the power consumption or your daily life, I would say. Yeah, so this is the platform that we use, especially this word EcoStruxure. If you have a chance to join our company or to partner work with our company in the future, then of course EcoStruxure, you hear this word at least 10 times in our office or from our colleagues or from me right now. In the next 40 minutes, I will mention more than 40 times EcoStruxure. You can count if you like. Yeah, and talk about the buildings. I would say that if you have very brief history about the buildings, so I'll divide it into four. You will see three only here, right? But it's four stages. The first one is the legacy. Legacy is just my personal insights. Actually, if I want to talk about like Stephen Hawking, a brief history of time, a brief history of buildings, I'll try to divide the stages into four, like legacies period, 1990s. So the value of the building, or people who design the building just for the resiliency. Okay, they don't want to be hit by typhoons, or even before they don't, many years ago, they don't want to be hit by the wild animals like lions, elephants, or tigers. Okay, so, but modern times, of course, is resiliency about the typhoons, natural disasters, thieves, or things like this, all right? So the major value is about the resiliency. And so one of the features are somewhat electric. Okay, net minus, you emit a lot of carbons. You burn the gas, you burn some of the houses, you burn the diesel, right? And also at the same time, they're very individual. That means that no connections between the buildings, okay? And functions, just reactive maintenance. Okay, something wrong, something needs to be repaired, and nobody will repair it until it's broken. Just like you see the old buildings in Jordan. Yeah, Jordan, you know what I mean. So nobody will remain or maintain the buildings or other power equipment or the other very critical assets until it's gone. Okay, so it's called reactive maintenance. And in the later part of this chart, you will see the reactive maintenance, the to preventive maintenance and predictive maintenance, then I will show you more. Sheltering, okay. Another is from the Stone Age. Then of course, buildings is very important for sheltering. Is the resiliency, part of the resiliency that we are talking about. For technologies, hardware is very important. So for example, the first one is of course the electrical one. Okay, there's a hardware, transformers with switches, with circuit breakers, and mechanical. Some of them will have lifts and part of the mechanical things, and also chillers. Chillers is partly electrical, partly mechanical. So it's a hardware dominated in those legacy buildings. And some software, if we talk about a little bit modern buildings, software is BMS. Okay, yeah. And then we move. Okay, many of you were born in, I think, oh no, is yeah, a lot of you Y2K actually, I see. And from 1990 to 2010, then I would say this period is the modern building. So in addition to resiliency, then we still have the efficiency. Okay, talking about how to make our equipment more energy efficient, or some of you may talk about at this time, some of them will talk about how to reduce the carbon emission, but it's not a norm at that moment. Okay, especially in my time or in this period, okay, early 90s, I was in my college or secondary school at that time. Efficiency is not a big topic. Okay, people will talk about buildings as just resiliency. Some of you may talk about how to increase the energy efficiency, but it's not big a topic. It's not a very big topic. And then in terms of features, electrical or some a little bit digital. Digital maybe some movement sensors at that time. Okay, just a very small and slight elements on the digital things. And net less. What is net less? Okay, you can reduce the carbon emission a little bit because of your increase in energy efficiency. And about the connection is still individual. Yeah. And then for functions, okay, shift from reactive maintenance to preventive maintenance, and more people talked about energy management at that time. So for the software, still dominated by hardware, and one more software is EMS, Energy Management System. Okay, not just the BMS. Okay, some people would talk more about energy efficiency. They need to monitor the energy consumption data of some energy intensive equipments like the chillers, for example. So then this software like an EMS. And then after beyond 2010, just 10 years ago, a lot of people talk about the smart buildings. Okay, I think in the past 10 years, and we are still in the period of smart buildings, even now. Okay, it's still a buzzword. Yeah, so resiliency, efficiency, and sustainability. Okay, sustainability, more focus on carbon reduction and step up our efforts on energy efficiency. Okay, yeah, add one more value. And the features are on top of the previous features, of course, some automation, and then people talk about sustainability, then the circularity, but just partly circular in those buildings. That means that some of the materials in the buildings, like the waste, you can recycle it and put it back to return it to the good use. Okay, so that's we call the circular economy in the city, but a building can also be partly circular. And connected means they can communicate between the buildings. So it's partly connected, especially we a lot of real estate groups. They have central platforms to monitor the performance, no matter in energy efficiency or sustainability. Okay, in a central platform, in the headquarters. So we call this partially connected. And then for the functions, of course, add on a lot of value add functions, automations, building to building communication, remote monitoring, space efficiency, energy management, and then preventive to predictive maintenance. Okay, a lot of values already adding. And also for the technology, then of course, we add one more layer as a digital, especially on the cloud-based analytics and also IoT, Internet of Things. Okay, yeah, for the hardware, okay, we add on the rooftop like solar panels or wind turbines like the renewables. They add one more, especially in the past 3 years, and the power utility is actively promoting the FIT, feed-in tariff, and incentivize the growth of our renewables in Hong Kong. And then e-mobility, for example, EV, electric vehicles. And just 2 days ago, Hong Kong launched our EV roadmap in the next 50 years, or not 50 years, it's 30 years, and we'll phase out the ICE vehicles, internal combustion engines, right? Yeah, so there's the e-mobility we also add. Now, not just about the traditional and legacy power equipment, okay, but something new. Renewables, especially, is like it's not energy consumption, is not energy consumption, but energy production for the renewables. And then we talk about the futures now. Buildings of the future will be the fourth. That is still in the future. That's our ideology, our targets, our goals, our ambitions. So what should it be? If we talk about the values and add one more, people centricity. What are the buildings? Because we spend 90% of our lifetime in buildings, actually, for most people. Okay, so it should be people-centric, and that's the value, and the buildings need to add. You can say building is like a living buildings. I like this term, actually. Yeah, it's like he may be the building. You can use he or she, not just it, not just, okay, it's not an object. Okay, it's like it has a soul. What's a soul? Okay, it's like it can help you make some strategic decisions, like your Siri on your phone, right? And they can know what you need, and they can give you the responses to help you make your strategic decisions, to make your life easier. And that's people centricity, and it will be the buildings of the future. Okay, and for the features, very on top of the things, some more improvements. For example, highly automatic and customized. Customized is like the buildings know your needs. Okay, you don't need to talk with them. You don't need to tell them what you need. At the same time, they have a lot of senses, just like your friends. You can treat them as your friends. They know what you think, okay? And that's the customization. The buildings, like they have the intelligence. They have the wisdom to know what you need, okay? We talk about, wow, it's very, you can see the movies in Netflix. Yeah, that's quite futuristic, okay? We are moving into this direction, although we have not delivered it yet, but that's the ambition in the future. We call it the buildings of the future. Okay, yeah, technologies, a lot of digital technologies you can use. AI, okay, they help you make the strategic decisions, and also robotics, more on the automation, okay, not just they know what you think, at the same time they can help you by actions. You need the robotics to help you to do the automatic actions. And then blockchains, of course, a lot of people talk about Bitcoins and blockchains. No, it's not just Bitcoins. They can, or blockchains, they can make use of the smart contracts and blockchains in order and to facilitate your peer-to-peer trading, some kind of cybersecurity, the blockchains. Of course, the cloud-based analytics and IoT and 5G, we still need to leverage the existing technology. You can see the transformation is from the hardware side and the software side, and the future will be about the digital things. Okay, your AI, your robotics, or make you customize and automatic, and that's the buildings of the future. So I will spend a little bit more time on the buildings of the future about the ideology. Okay, and before I move to some analytic things, to give you some more substance on figures, because your students, some of your students, and then our group, our company has found some figures to substantiate our ideology in these 4 areas. For example, the sustainability, you know, 40%, around 40% of carbon emissions come from our buildings. 40%, which is big. A lot of people think that's power generation. Okay, but actually, it's buildings. No matter it's on-site buildings or indirectly from the power utilities. Okay, sustainability, about 40% of our carbon emissions from the buildings, so you need to reduce it. And then resiliency. Okay, you know that in 1 year, we have 365 days, and we have more than 350 natural or man-made disasters around the world on average. Okay, so you can see it's 1 disaster per day. Yeah, so buildings need to be more resilient, and not just to natural disasters. And also because of the very rapid developments of the computer world, cybersecurity is also an issue right now. And efficiency, And 30% of our energy is waste in buildings, especially in chiller systems and also in the other areas. So it's quite big, actually. Yeah. If you are talking about end-to-end from the power utility to the end consumption in building, and it can be up to 80% of energy waste. Because of we need to survive, we need to live, and we waste 80% of our energy consumption in the world. It's tremendous. You can see, yeah, how wasteful human beings are, and that's why we need to focus more on the sustainability. And the last one, talk about people-centric. And I gave you this figure before, 90% of our time in indoors, or most people. Okay, you may say, oh, I love hiking so much. I go to hiking every day. It's not 90%, but for most people, okay, especially in the, like me, I need to work in the office, not less on the site work, and then really 90% of the time in the office or at home. Yeah. Okay, even though I dine out to enjoy my dinners or hot tots and still indoors. Okay, not barbecue. Barbecue is say outside, but most of our time spent indoors. So you can see how important are the buildings to us. That's why you need to be very people-centric and very human, actually. Yeah, and so that are the 4 key values of our buildings of the future. Just to recap, I hope you can remember these 4 values after this webinar: sustainable, resilient, hyper-efficiency, and also people-centric. These will be 4 big or key values of our buildings of the future. And that's also the ideology of our Schneider Electric. Okay, talk about this. I will come to this or try to elaborate more on each value. If we talk about sustainability, then all the buildings must be net zero by 2050. Okay, if we talk about Schneider Electric, then our company target is 2030. We have to be net zero, 2030. If 2025, okay, 5 years in advance, we need to be carbon neutral. Yeah, and that's our goal. It's very ambitious, to be very honest. For a company with 140,000 employees around the world, this is like a mission impossible. But we set a very stretching target, and we need to save the world, hope to save the world, and we set a very ambitious targets in our carbon reduction. And all the buildings in the world, we also would like to add value to the sustainability, help the other people or customers to move towards this kind of target by 2050. Yeah. So how can we do so? The first thing, electrification, because electricity is the most energy efficient or way of power of energy transmission in the world. So we need to maximize our electrification in those buildings. Okay, yeah. And right now we may use, in some buildings, we may use some other fossil fuels like the gas or like the a diesel, for example. Okay, not in Hong Kong. Okay, but they have on-site carbon emissions. That's why we would like to try to do the fuel switching from the other fossil fuels to electricity. Especially we talk about, oh no, electricity. It comes from coal-fired power plants. It comes from gas-fired power plants. Well, you still emit the Scope 2 emissions, but don't forget, and we have more renewables in our fuel mix, not in worldwide, not just in Hong Kong. Hong Kong is low actually. And so if you can convert your fuel from the other fossil fuels to power, then it also means that you reduce your carbon emissions, okay? And then the second thing is the proactive energy management. Okay, yeah, we have a lot of analytics right now, no matter it's from Schneider Electric or other companies, and every day, every month, every year, you can see a lot of technology analytics to help you to do the energy management. And a lot of people, property developers or facility management companies, they are asking those technology suppliers to help them to better visualize and manage the energy consumption. Okay, and operate positive energy buildings. Positive means you, as I said before, you install the renewable solar power, solar panels, and also the other kinds of renewables to generate energy and feed it back to the grid. Of course, right, Hong Kong, thanks to the power utilities, you can enjoy some economic benefits or incentives for you to do so. And take this chance, take this incentive to build more renewables. And that's also what's happening around the world. And then the fourth is more resource efficient. We talk about the building management system, how to integrate them with BIM. I will have some part I'll talk about the BIM. If you noticed my agenda before, what is BIM? Is sorry, I need to change. Building information modeling, yeah. And then last one, create a sustainability retrofit. Retro commissioning is a very it's a hot topic in Hong Kong right now. We have a lot of old buildings and they are not very energy efficient, and you need to retrofit some equipment to help you better visualize and manage the energy consumption. That's retro commissioning. Resiliency, you can see typhoon here, right? So it's a natural disasters. As I said before, every day you can see one disaster around the world. Okay, and at the same time, because of COVID or other, no matter it's a pandemic or natural disaster, people should have the ability to operate your buildings, okay, remotely, and so we expect 70% of the building's functions can be monitored or controlled remotely through the internet, through the IoT devices, okay, or through the other analytics. Yeah. And yeah, we talk about this power reliability. So although, yes, I know that the power utilities on the supply reliabilities in Hong Kong very, very good already, over 99.99% in Hong Kong, but just in some other countries, they are not very reliable. So we also, the buildings should also consider some UPS, uninterruptible power supplies, to help them to better or to further the reliability in those buildings. And this one is a new topic over the past 3 to 5 years. It's a cybersecurity. Okay, not just about the power, not just about the electrons, but also about the digital. Okay, and especially right now, a lot of hackers, a lot of people, they are very professional in those kind of things. They try to hack into your systems, and every week or every month we hear some news about the cybersecurity issues, no matter in Hong Kong or overseas. And we need to strengthen our cybersecurity, especially that we rely more and more on the IT systems, like the IoT, like the EcoStruxure platform that we have. And just to assure you that we have a very professional team of cybersecurity people in our company to make sure that our digital systems can work very robustly and very resiliently. Yeah, and the last thing is a very critical structure assets we need to protect, like the transformers, like the circuit breakers. Then if it goes wrong, then of course the whole buildings will be out of power supply. Yeah. And benefits from the hyper efficiency. Hyper efficiency, we will ask, what's the difference between hyper efficiency and also sustainability? Then hyper efficiency, we'll try to twist it or try to look it on another angle, as the more on the efficiency on the data side, like how we make use of the big data in artificial intelligence to help you to manage your operating costs or improve your productivity. Okay, and those are the things that we try to leverage our data to make our life more efficient. For example, as I said before, like the system or the buildings will help you make some strategic decisions to accommodate your needs in the buildings. The first thing. Second thing, space efficiency, especially after COVID-19. And we talk about how to make use of better use our space, social distancing. At the same time, one trend in Hong Kong is like hot desking. You know, hot desking, you don't have a fixed desk, just like our office. We can sit anywhere we like. Okay, we are just like a nomad. We can sit, okay, we're office nomads. Okay, we can sit anywhere we like. So how to better utilize our space? Then we can have some devices to monitor. Then I will introduce to a little bit later in the later part of our presentation. And better use of energy, of course. Yeah, we talked about this in sustainability before. And the last topic is the key elements of our buildings of the future is about people. So people and buildings will be integrated. Then you will, whenever you are in the buildings, like office building, you can increase your productivity, you can increase your satisfaction, you love your work much more than before, and a better environments like the IoT, IAQ, indoor air quality. Yeah, And also the environments, you will love this kind of very posh or stylish environments and very comfortable, not just the very traditional kind of things. You have piles of documents in the office. Okay, so this will be the buildings of the future. Then I will come to the next topics. Now, we've already known the building should offer 4 key values in sustainability, resiliency, hyper-efficiency, and also people centricity. But one thing, if the building is operating and its performance will decrease over time, that's why we need value engineering. What is value engineering? When it decreases over time, then you will see some value or see some need to increase the value of a building. How we can do so? A lot of tools you can do so, but I might, because of in the interest of time, then I will focus more on the digitization, and it's also the core business or on the strength area of our company. So I will introduce two digital tools like BIM and also our cloud-based and IoT-enabled analytics to show you how we can leverage this kind of technologies, digital technologies, to help you to do the value engineering of the buildings. Okay, now come to some theory part. You can see the life cycle of a building. Oh, sorry. Okay. Oh, sorry. Oh, don't know what happened. Okay. Sorry. I don't know why I suddenly jumped to the a few slides later. Okay, you can see the life cycle back to this normal things. Okay, so sorry. Oh, I don't know what happened here, and but I'm okay. Here first. Okay, don't talk about the last slide, but just a very introductory slide about the life cycle. And here you can still see the life cycle of a building, right? And it lasts for 30 years, and you need to do the renovation to extend the lifespan of a building. And you can see 3 very major key stakeholders throughout the life cycle of a building. The first one is a consultant. For some engineering students here, especially you're in your final year, you're applying for jobs, and most of them would like to go to consultants like AECOM, Arab, or WSP, right? So you can see their participation in the building is the first 2 stages, the first 3 years, like the design. This year is like the design. You need to write the specs for the landlords. At the same time, they will carry out the construction. You need to do the site management. So for the consultants, they're more focused on the the early life cycle of a building, like design and construction. And then next stakeholders like contractors, so they mainly do the construction within 2 years. Okay, and then the next one is facility management. Okay, you can go to the property developers like Cheng Kong or Sun Hong Gale or like that's why okay, and then your work more focused on the O&M. This part is O&M. That is the longest lifespan of a building. 15 years, maybe 20 years or 25 years. That's the main part or the key part of the life cycle of the building. So we'd like to give you some very high-level figures is around, and I will show you later, is just to give you a heads up. 70 to 80% of the life cycle cost of a building actually is in this stage, O&M. Don't say O&M don't need to do anything. Most of the costs will go to the construction, but not really. O&M, a lot of things you need to do after you graduate, or some people maybe in the existing consulting firms or working in property offices or facility management offices right now. They have a lot of stories to tell, and maybe they can tell you in the next webinar. So one thing, back to this graph. So what are the problems? The first thing is not much overlaps, as you can see, among these 3 stakeholders, right? Okay, so first thing is they will just take care of their own part, okay, because they don't want to, they have no responsibility to go extra miles to take care of the others. So that's the first thing you can notice, not much overlap. And the second thing is, this is a very typical, classical economic problem. It's called principal agents problem. That means that I just want to do my best, okay, in my own area. So I will, or if you put it very frankly, is I just do my part, even though it is at the expense of the other people. Okay, I just want the best out of my own interest, and I don't care the others. And that's the principal agent problem. Okay, so you can see this kind of the division of responsibilities throughout the building life cycle. And then the next slide, you try to overlap, you can see this one. Okay, so we don't have integrated system for the project management, okay, and the communication among all the key stakeholders, because we don't have much overlap, okay, and we don't have any equipment or devices for our defects detection and also the correction. And you can see if I can draw a performance. Okay, this is not this is just a very indicative figure. Okay, you can see this is the performance of the building and the design. Everything on the paper is so perfect, right? Okay, design consultants are very professional, and to design the building, the performance is 100%. Is everything is so perfect. And construction, when it comes to contractor, they will try. Of course, they will try their best to upkeep the performance of the buildings, like the quality, but you know, the site constraints, like problems, sometimes you need to undermine the performance of a building, and so there will be some deterioration in the performance of a building. And during the TNC testing commissioning, you can find some defects and they fix it, and that's why the performance is a little bit boosted a little bit here. But throughout the whole O&M stage of a building, you can see the performance is declining here. Okay, so what is the problem of this performance decline? So for example, a lot of problems, just four of them, a major one you can see, I can say, excessive energy consumption. Okay, it's not energy efficient. Yeah. For example, the chillers, the energy efficiency will decline. Lower reliability or resiliency in some critical assets, like transformers, like circuit breakers, bus bars. Okay, you will see some kind of unexpected outages in your power supply. And the third thing is, yeah, if you are you're working or living in a building, then you feel uncomfortable because of the declining IAQ, indoor air quality. Yeah, and also because of the maintenance or energy consumption, or yeah, some kind of repairing work, then of course your OPEX will increase. Then what should be the ideal situation? The ideal situation should be like this. Try to make them like a straight line, the performance, okay, to be consistent throughout the whole life cycle of a building. And then that's why we need the digital technology. How it works, it will help you to you know, enable the closer interface of the stakeholders and give you a more smart project management and do some real-time performance monitoring. Okay, you have a lot of sensors, you have lots of devices in different parts of the buildings to help you to monitor the performance, and then do some retro commissioning. That's here. If you have some devices to help you to do some real-time performance monitoring, then of course you can boost your performance, yeah, by retrofitting or repairing, replacing some faulty equipment. And that's here. We try our best to upkeep the performance to the original standard, the design standards. Okay, so one thing, you can see the graphs are different. Then I try to overlap these two graphs. You can see this, the blue one is here, right? Yeah, you try to overlap these two graphs. The first one is the traditional method. Okay, business as usual. We don't do anything. Okay, very traditional way. That's the declining performance. If we do something, use the digital technologies to help you, then you can boost back the performance up here, right? So try to overlap, that's the difference. Okay, what it means the difference? That's the value. That's the potential for value engineering. Okay, what we need to do is to find ways to realize these kind of values. Okay, yeah, so what we can do. Okay, value can be in the form of efficiency, reliability, resiliency, and comfortability, which are quite in line with what we talk about, the four major values of a building. And if you're coming from the real estate segments, then if you're a property or landlord, okay, property owners or landlord, you talk about, I want to have a higher value of my buildings. So higher value, it also means a higher valuation, especially in Hong Kong, quite a lot of private equities coming into play in the real estate market. What they do is they buy the buildings and try to renovate it, like add a lot of digital technologies and increase the value of the buildings. And then after several years, they will sell it out, and it will make the buildings a more valuable, higher valuation. Okay, and in terms of technology, of course, at the same time, I need to say a lot of things you can do. In terms of the technology, then I would just like two examples in the interest of time. The first thing, in your design and construction stage, then this two. Then we use the BIM, as I said before, building information modeling to help you to realize the value in this part. And in the O&M, yeah, the longest stage, in your life cycle, then you need to use some cloud-based and IoT-enabled analytics to capture the value. Yeah. Okay. So as you can see here, yeah, BIM here, and also the analytics here in the O&M stage. Okay, BIM, building information modeling. That's the first technology I would like to talk about, and then the next one will come to the analytics. Yeah, give you some statistics before we begin our part here. You know, the buildings industry ranks the 21st out of 22 industries of digitization. It means that it's not very advanced in buildings. Okay, the other industries, for example, like maybe pharmacy, or like the other industries or computers, or other manufacturing, they deployed a lot of robotics and AI, then of course they are more advanced. You see that we have still, in the building industries, we still have a lot to go in order to deploy the digitization. And then the second figure is 40% of operational inefficiency during the design phase. A lot of things, 40% of your efforts of value wasted already, right? During the design phase. When we talk about the construction phase, then 96% of data we capture actually goes unused. Okay, we capture a lot of data. Okay, we have a lot of sensors, but we don't use it. Also a waste. Okay, 96% of the data. So the problem is, one of the ways we need to consider is how to make use of those data we capture, okay? And then we need to BIM. So I will say we have 3 or 4 levels of BIM. A lot of people know BIM 10 years ago. The word already existed for more than a decade or maybe 2 decades. Oh, level 0, a lot of BIM, yes, I know. Okay, drawing, CAD drawing, AutoCAD, right? So it's just the lowest level. And actually, that's the origin of the BIM, to be very honest. And the technology their evolution is from some AutoCAD drawings, and then they move on. Okay, 2D, 3D. Quite a lot of people will talk. If you ask what is BIM, a lot of people still answer you, 3D. Okay, you can rotate it. Okay, very nicely, perfectly. Now I really love this. Okay, 3D modeling. Okay, this is still just on the level 1, I would like to say, and then level 2, one more up. Then you need to better manage your model with different tools. A lot of different tools, not just the AutoCAD, not just the drawings, but you can incorporate or combine with a lot of different tools to release the value of your BIM models. And I will show you a little bit. Okay? And then level 3, integrate 5D. We talked about 3D before. 3D is like a cube, like you have the height, you have the width, you can have the length, but what is 5D? Okay. Stephen Hawking didn't tell you what is 3D. Then BIM tells you it is, you can add is the time and also the cost, okay? And then you, as I said before, different parties or different stakeholders in the first 2 stages of the buildings. And what they can see is different things, and they don't have enough communication, and they don't have enough overlap. So BIM also provides a single platform. Okay, everything can refer to, try to strengthen the communication among all different parties, and that's the thing that BIM can help. Okay, as I said before, you can use the 3D, 4D is the time, and then add with the cost. Okay, combine them together to have the 3D. Some people here will talk about, okay, I have 10D, I have even more. Yes, just depending on how you define the dimensions. Okay, you just some more functions or some more data, different types of data you can monitor. But right now the BIM, I think the very basic requirement is you should have 5D. Okay, not just the 3D modeling. It's not like a space, especially with the time and the cost, right? Okay, for those data, you can do some simulation, you can do the forecast, not just drawing. You can compare, you can use the digital twins, okay, and optimize. Optimization is very important in site work, okay, yeah, and especially we talk about the cost efficiency, then optimize how you make use those kind of digital technologies to help you optimize. Yeah, you need the BIM, especially in the first 2 stages, like design and also the construction. Okay, now it shows you a lot of different parties are working in the site, and actually a lot of different parties are working on the BIM platform. Okay, so that how the BIM can help you to give you this single source of truth to different parties. Try to strengthen the communications, try to overlap them all together on single platform so they will know they can communicate Yeah, they can solve the problems, they can fix the defects quickly. And this is the ideological framework of a BIM. So we talk about data in the past. 20 years ago, BIM is about the data. And the data, if you add how the data add more value, try to transform them to the information. Okay, we call it know what. Okay, know what, information, a lot of information we are hearing in the world, and it's the same, okay, in the BIM world. And information with more meaning, that it becomes our knowledge. Okay, that's why you study at Hong Kong UST, to get the knowledge, not just the information, the knowledge, some meaning behind. Yeah, not just the information. You can have a lot of information by Googling, but the knowledge you need, some meaning behind. And then one more layer up is wisdom. Okay, in the past, just human has wisdom. And right now, we try to make the use of our AI, artificial intelligence, to help the machine, not just by learning, and also by thinking. And that's the wisdom. Okay, if you have wisdom, if you are witty enough, you will ask why. Why? Not just how, not just what, but you have to know the underlying reasons behind. And that's why I learned at Harvard is, okay, at Harvard, it's very important. You come to Harvard, come to UST is not you want to learn things. The true meaning of education is to ask more meaningful questions. That's the wisdom. Okay, so you come to UST, you get a lot of knowledge. At the same time, after you know the knowledge, you need to ask more meaningful questions. And that's the wisdom. And we hope we can incorporate those kinds of wisdoms into our platforms, systems, digital world. So they will think like human. Yeah, that's the thing we need to do. Okay. Yeah, and how BIM can provide more value. Of course, you can add more smart sensors, these sensing technologies like a human and machine and materials, method and environment, not just about the very low level sensors like temperature, humidity. Okay, you have a lot of different kinds of sensors to give you real-time data for you to monitor the performance, the progress all the time, everywhere, every time, okay, to everyone. Okay, and then next, automatic data input and visualize management. You don't really need to have the manual data input. You don't need to hire a data input cloud. The sensors, they get the data and collect the data already transmitted to the system for them to sort it out and then to make it more visible, visualizable. It's a very big name actually. Yeah, so help you better visualize the entire progress, the process, and that's the way they can help you. And then one more thing, we talk about AR, VR, like virtual reality. We can also incorporate the use of visualization technologies to help different people. You can see there's different stakeholders on the platform before, right? Have them really visualize, yeah, the real situation. Okay, so that you can know the world or the site remotely from different parts of the world. Yeah, I know it's quite sky high thinking, but that's the ultimate goal of the BIM system. Okay, and then we can add more digital twin. Okay, what is digital twin? I know that computer engineering students here are very familiar with this and you're an expert, so just bear with me. Yeah, so it's a digital copy of the physical object. Actually, it's called digital twin. It exists in the digital world. It's a virtual world. Yeah, and we rely on the sensor to help you to collect the data and to update the digital copy. So just like you have a brother, a twin, but he does not live in the real world. He lives in the cyber world, and you keep feeding him the data, not just the food, not the food. Okay, he doesn't need the food. He needs the data. Okay, so he'll give you just like the simulation and a copy of you existing in the digital world. So that's the digital twin. And I would like to mention one thing is a lot of people will think about digital twins exist on assets, just like I have a digital brother. No, it can enlarge, extend to the whole city. Okay, and actually in the UK, they have already conducting this kind of program. They try to build another Britain digitally, and it's already back in 2018. They call this the Germany principles. Germany. Okay, twin. Okay, this zodiac sign, right? Yeah. So this kind of technologies will hold very considerable promising potential in the world. Okay. Yeah. A lot of very interesting things are happening in the digital world in the next 10 years. So if you are studying or you are an engineering student right now, then you have a lot of things to do in the next decade or two. And the final part of our presentation, and yeah, I need maybe overrun a little bit, so sorry about this because I have a lot of things to say. And that's the last part, is a cloud-based and IoT-enabled analytics to show you the buildings of the life cycle course. And I've already given you a figure before, like during the O&M stage. And then around 60 to 80% of our life cycle course will be on the O&M stage. So this just you to give you more visualized picture about the cost distribution. So for the first two, design and construction, you just account for these two stages, account for 20 to 30% of the whole life cycle cost. And when hand over to the landlord or the facility management, then a lot of costs will spend throughout the whole lifespan. It accounts for 60 to 80%. If we don't do well in this O&M stage, it means that we waste a lot of value. And our goal is how to keep up the value, restore or recover the value through the O&M stage. And that's what the technology or digital technology could help you. Okay, back to the real eco-structure again, but I fill it up with our offers. Okay, not to sell anything, but just to give you some more examples. What are the connected products? As you can see, there are all the hardwares, as you can see here, right? They can be put into very good use in the buildings. And then what are the edge control? They are, okay, in our Schneider language, it's called experts. It's software to help you to monitor the performance and some kind of control you can do. Okay, it's turn, switch it on, switch it off, right? Yeah, so the software layer. And then up more is the analytics, okay? It can help you to make strategic decisions. It can help you analyze the data to see the performance. What are they? Okay, I will mention we have 20-something advisors over the world, but in Hong Kong or more related to the buildings, or just in the interest of time that I don't have enough, otherwise I will talk the full day, then I will just mention 4 advisors, how they can help the buildings to add more value. Okay, building advisors, asset advisors, and power advisors, and workplace advisors. Okay, so what are they? Building advisors, I will tell you. I don't go through the details. I know that you feel is so wordy, but just in one word, it's called energy management. Building advisors, the value proposition is more on efficiency. How you can use the digital technologies to better manage the energy consumption, okay? And the asset advisor is the asset reliability. What are the assets, okay? Assets are circuit breakers, switches, okay? And I will show you more examples. The critical assets to your power supply. And then power advisors to monitor the power qualities. In Hong Kong, sometimes it's really inevitable that, especially in the summertime, we have a lot of lightning, then you can experience some fault dips. And so it's a power quality problem. I will show you one graph, okay? And in Hong Kong, we have 2 major power quality issues. The first one is fault dips, and the second thing is harmonics. If you are coming from the electrical background, you know what is harmonics, or IT background, or computer engineering, you also know what is power quality problems. And the fourth thing is workplace advisors, the space efficiency, how to make your workplace smarter, okay, more comfortable, to make all the employees more productive, or to lower the operating cost of the office or the buildings and the workplace advisors. Okay, so I will give you just a very brief overview of all those advisors. I said before, I'm not going to sell anything, but just to show you how the advisors could add value in terms of the energy management or asset reliability or space efficiency or things like this, okay? So we have the building advisors, and what are the functions? Of course, real-time monitoring of the energy intensive assets like the chillers. At the same time, not just the energy management, but also the health checks. Okay, like the doctors, you go to see the doctors, you do the body checks. But very different is do the body checks maybe once in a year, once in 2 years, but it's real-time checking the health of your critical assets. If they find any problems, then they will report directly to the experts in our company and also in the client side. And one thing is non-intrusive open platform. It means that no matter which brand name, no matter it's our company or other companies, the data is totally transferable. It's BMS agnostic. It means that, okay, no matter what brand names of your BMS, it can still fit in the data to our advisors. So, and the world is like this. Actually, the trend is more collaborative. No matter in the digital world, is more collaborative, no matter which brand names or companies you are using, right? And that's the future trend. Yeah. And how we close the loop. Okay. Yeah. So the data coming from the customer side, and we send the data to cloud. Okay, cloud computing is very important in IoT system. Yeah, and they have the data, they show the data to experts to do the analysis. So what the data will go to after they reach the cloud, it will go to our company. So we have the experts to analyze the data. They find any problems, they will report to the customers. At the same time, the customers can also visualize the data to monitor them. If they find any problems, of course, they can fix it immediately. And then for our company, then if we find any problems, of course, we will report back to the customer and try to find out the solutions to help to solve the problems, to give you the recommendations. Sometimes the problems are more long-term, not very urgent, then we can work out the solutions together. And then we carry out the recommendations, the solutions, and try to validate whether back to the normal one, okay, restore the value, okay, because the performance is declining, as you can see in the previous graph, right? And then after some solutions or remedial actions, then we restore the value, okay, return it back to the normal. Okay, this is one. And one of the benefits, of course, we do these kind of things for something, right? For example, okay, we just did some survey in our customer base. For example, the issues, okay, 80% of the issues can be resolved remotely because it's cloud-based. As I said before in the resilience part, right? 70% of the building's function should be monitored, can be controlled remotely. This is one of them. You are able to control, to monitor, to resolve your issues up to 80%. And the second thing is unscheduled maintenance. Okay, unexpected outage is decreased by 30% because it can do the health check for the critical assets at the same time, not just the energy management, okay, energy efficiency. And third thing is about the occupants' comfortability, the complaints. A lot of, if you are coming from the facility management background, and a lot of people, the tenants will have complaints no matter it's too cold, it's too hot, too noisy, or a lot of things, right? So because we can monitor and solve the problem very quickly before they make the complaints, then we can reduce it by 33% of the complaints. And lastly, of course, money talks about the energy efficiency gain, then energy cost can be reduced by up to 20% by monitoring the consumption and so change the behavior of the tenants or the facility management. Okay, it can give you data and you try to fix it. Yeah. Then is so you can see a lot of different benefits in different dimensions, as you can see, not just energy management, but some value add benefits you can see. And the next one I would like to mention is the asset advisor. It's more about the critical assets monitoring. Okay, so you can see another loop here, right? It's the same loop actually, but I would like to introduce what are the critical assets here. For example, transformers. Okay, in Hong Kong, most of the transformers are owned by the power utilities, but in other places, not really. Or in Hong Kong, in some places, especially the customers with a high voltage supply or medium voltage supplies, then they will own their own transformers. Then it's very critical to them. Once the transformer is gone, then consequences can be very severe. Also, switch gears, no matter is in medium voltage, low voltage, and the VSD voltage is a variable speed drive for the industrial plants. Not much in Hong Kong, but in other places like China, they have a lot. They still have a lot of industrial plants, or in the US, they still have a lot of plants. And thermal monitoring, like for the bus bar, okay, especially in some joints with some screws, then it's the hotspot. You need to monitor the thermal, the temperature. Okay, otherwise it will be overheat. and it will be gone. And environmental factors like the temperature, the indoor temperature, and the humidity, and sometimes you need to measure the noise level. Yeah, that's the, and air quality, for example, and or dust levels. Okay, they are all the things that we need to monitor. Again, we send it back, okay, the gateway to collect all the data and then send it back to the cloud. And the cloud, they have the data, they will give our experts and also the customer to monitor, to analyze, and then figure out our solutions together. Once we find any problems, then we can find it at once to prevent it from happening. And we call this kind of things a predictive maintenance. So if you can still remember what I talked about is 30 years ago, 16 minutes ago, then we have in some legacy buildings, we had it's called reactive maintenance. We don't do anything. When things go wrong, then we'll fix it, replace it. Okay, yeah. And then now, okay, people will talk about preventive maintenance. Okay, try to do some scheduled maintenance in order to prevent the problem. And now with the analytics, with the digital technologies, you can do the predictive maintenance, just like you have the crystal ball. The crystal ball is in this kind of asset advisor. Then it can monitor any defects. For example, in transformer, partial discharge. It is a signal for the problem. Okay, partial discharge, when it happens, it shows that there is some electrical problems in the transformers, that it will be gone very soon. Yeah, unexpected shutdown. Okay, so just like your body check. Okay, you need to monitor different indicators, and then this kind of asset advisor will give you the real-time figures, and then you can find the problems in advance. And by doing the predictive maintenance, you can lower your costs actually. But if you are still sticking to the reactive maintenance, then once the equipment is gone, the replacement cost is very high. Then here shows the cost savings. Okay, yeah, 80% cost savings if you can do the predictive maintenance. Yeah, reactive maintenance, because you use the equipment until it's gone, and everything is so unexpected. Yeah, the consequential cost of the reactive maintenance is very high. If you can do the predictive maintenance, you can solve the problem in advance before it happens, before its impacts spread around. Then is the lowest cost option. Okay, here is the philosophy behind in terms of the economics. Okay. And then power advisors. Power advisors are lots of PQ problems, power quality issues around the world. In Hong Kong, then is very common one is the VODIP here. And in America, it's called VOSAX. Okay, just a very short drop in the voltage level. Usually during the lightning, when the lightning strike the overhead lines, then it will cause these kind of problems. If you have some very sensitive equipment, then it will be locked or tripped down. Okay, and another problem is harmonics. The waveform is very irregular. So harmonics means that it will cause overheating, especially the harmonics, overheating of the transformer neutral. That's the major problem of the harmonics. And where are the harmonics coming from? It's from the data centers, especially in Hong Kong. We are building quite a lot of data centers, especially around the Tseung Kwan O area, and then in Kwai Chung and Sha Tin. Yeah, quite a lot of harmonics. They are pollutants actually. Okay.
Hey,
oh, sorry,
Kelvin,
I hear some voice.
Kelvin,
Yeah.
I don't want to disturb you,
Okay.
but we have to finish at 2 o'clock. So
Yeah.
I do want to get some Q&A time for the audience.
Okay. Okay,
so,
maybe I'll quickly go through all them. Give me maybe 3 minutes, because we so sorry about that. I have a lot of things to share actually, and I would like to give me 3 more minutes to go through all the problems. Well, not the problems, all those slides. I think I should have 3 more slides to go. Yeah.
Sure.
Okay. And the benefits I don't want to talk about. Okay, the system configuration, how we can make use of different power meters to check on the data quality and also the electrical network health. And that's the principle behind our power advisors. And the last one, people, especially in Hong Kong, that more use, they have more use is the workplace advisors, like how to monitor the space efficiency and well-being in offices by monitoring the IAQ, by monitoring the, here it is, the space efficiency, the comfortability of people, and also the people flow and area. Yeah, especially we are talking about, I mean, in Hong Kong, the property prices and also rents are very high. So we need to make better use of our space. Okay, by this kind of advisor for analytics, then you can replan your office space, try to minimize the lease or the rent to make you more space efficient, and that's the thing. And here is the last slide, as I promised Professor Hong. And we talk about the future. The future actually is now. And as you can see, we have a lot of different reference cases around the world, no matter it's in Europe, in Hong Kong, in Asia, or in different places. And we are moving towards the buildings of the future, no matter what asset types, like the data centers, like commercial buildings or hospitals. And this is a worldwide trend. That's the last message I would like to bring it to you. And the future has come already. And we talk about tomorrow, and actually tomorrow has become today. And we cannot resist this kind of mega trend. Yeah, and especially you are students at Hong Kong UST, think about your career, think about your future in this way. Then you will have a more meaningful life, yeah, in the future. And that's the last message I would like to bring to you. And open to questions.
Thank you so much for
thank you very much.
Very rich presentation. Actually, USC also built the first digital twin for our entire campus. I think Jack is here. Professor Jack Jiang is here. I'm sure he has some question about BIM and so on. But before that, let me ask you just two questions, which to me is number one, is that are there a low-hanging fruit that we can do today without a lot of technical barrier? What are those things we can do today to get some early winners? And related question, what are the barriers? We don't do it today because people don't understand, don't invest, or simply there's no regulation and no incentive. What are the things that prevent people from doing more?
Yeah. And actually, in economic sense, then there is a marginal cost of energy saving. So sometimes we really are the low-hanging fruits. Okay, for example, you need to turn off the lights when you leave the office, then it's a really low-hanging fruit, and you don't really need to incur any cost. And you need to install more sensors, then it will be the next. And of course, if we talk about the greatest marginal cost with the installation of solar panels or renewables or other digital technologies. And I think for the low-hanging fruits, we've already done enough, and by active promotion in the past 2 decades. And right now we need to move forward. It's not just the low-hanging fruit to me, and because we've already done enough, and just if not enough, then it's just a matter of education or promotion to the employees or people around the world. And in the future, then we really need to step up our efforts, especially after the Paris agreements. We have the world is moving towards a low carbon economy. Then one thing because I'm also taking the post or the role, just a role, is not a position, in Schneider Electric as a sustainability lead in Hong Kong. And one belief or one philosophy that I really want to emphasize is sustainability needs cost, sustainability needs actions, efforts. Yeah. Okay, low-hanging fruits we have done. Okay, and at the same time, we really need to step up our course and also efforts to do more on sustainability, and that's the thing that I really believe.
Jack, you have a question?
Okay. Yeah, sorry. Yeah. Too bad it's online. Yeah, thanks. Hi,
MK.
Yeah,
okay,
I'm Jack.
thanks.
So too bad it's online. I really want to meet you, and then because we have many common grounds. And for the information, I've been teaching BIM at Hong Kong University for 7 years and setting up the standards, etc.
Wow.
Also,
wow.
Also involved in the Green Building Council. So we are working on the Hong Kong University digital twin, and we have similar ideas about connecting the energy with the dual model. So I have a couple of questions, and then hopefully maybe in the future we can exchange more. So one question is, I think I've seen many cases, the green buildings, they are designed as green building, but sometimes it's not the technology problem. It's actually the human problem. It's the human behavior. So can you share some experience about how the technology actually can change the behavior of the human so that really can realize this kind of sustainability? Second question is, I've seen about the existing buildings. So yeah, many existing buildings that have many limitations in the system. For example, they don't have subterranean or many the cost issue. Then this PM etc. is not cheap. So how to really adopt this kind of technology to existing buildings so that it's green?
Yeah, very good questions, and I really want to answer those questions. And I also I'm asking myself all the time. The first one is about people, and really right is that technology is for people, but the biggest barrier is still people. The biggest technological barrier is still people. We are working in the technology world, and that's my feeling. Okay, we want to promote those technologies to people, how to change their behavior and ask them to adopt. And the people already in their comfort zone, they are really reluctant to change, especially some just turn off the lights, and you still need to educate them many times. So the first thing to change the mindset of the people, of course, is through the education. And I'm sure all the audience here, like your students at Hong Kong UST, they have been educated enough, and when they go to the society, then they will exercise the best efforts to save the energy consumption, and also step up our efforts in sustainability. And the second thing is I would like to emphasize more on the commercial world, how we facilitate the buy-in of our clients, because they are also people, right? How they buy in the technologies. Of course, then we will start from small. Then we will do some pilot tests to prove the concept. We call it POC, proof of concept. And because technologies, a lot of people, wow, I love technology, I love innovation, but it's more like a slogan. And people, if you ask their bottom of their heart, then they are still quite reluctant to do it. They are what they're saying. Then we need to identify the people, the clients with the most openness to innovation and technology. Then we can try this pilot, and then to scale up to commercial projects. And what we can see over the past 5 years, when we do the pilot, we are very successful. For cases that we are very successful, then the other people, the other companies will know, and they will ask us, approach us proactively, not we approach them. So what you can see is people want to know the examples. So the first thing we need to do is to set up a very good example with some pioneers, that I would like to say. With those pioneers, is you can demonstrate the success, you can have very proven cases, then of course the other people will follow through. But it really takes time, you're right. Yeah, it really takes time. So in order to facilitate the buy-in of people, and to us, people is always the biggest barrier, although technology is always for them. And the second question is,
I don't know whether it's the time limit. So see whether anybody have other questions first.
Yeah, Jack, do you mind to host the meeting, because I have to leave to chair that.
Okay, yeah, sure. Okay.
Kelvin, thank you very much.
Really, thanks a lot for inviting me to this.
Thank you so much. Because unfortunately,
thank you so much.
Now.
Yeah, it's time's up, and so sorry, longer than I expected. Yeah, so sorry about this. I talked more than because I'd like to hear more questions. And thank you very much, and would like to appreciate another chance to come.
Sure, Jack. Thank you. Please continue.
Yeah, thanks. Thank you.
Bye.
So maybe we can continue the Q&A session.
Yeah.
So the second question about the existing buildings, I think maybe 5 more minutes.
Yeah. Okay, please. Your question, second question, then I haven't answered.
About the existing buildings. Yeah.
Well, existing buildings, and we have some projects. Retro commissioning is very important. A lot of people are talking about retro commissioning, and right now we're handling some projects requiring retro commissioning of some submeters. The first thing is about energy management, is you have the data visibility. A lot of people, they don't know how the energy is consumed on equipment levels. For example, chillers, I know that it's very energy intensive. It consumes the most of energy in our buildings, but actually I don't know how much it consumes. I just assume it's around 40 to 50%, but we don't know the accurate or precise amount of energy that it consumes. And the second thing is the pattern. Okay, because the load pattern will also affect how you manage the energy. So that's why we need the analytics. Oh, so analytics, you need cost, you need to invest, and you can think about, okay, not to do the promotion of the other companies, power utilities, they have eco building funds. I think it's a very, very good initiative to assist, support the commercial customers, okay, who really have concerns in their economic needs. Then you can try to think about talking with the power utilities, how to make better use of their eco building funds to implement those energy saving initiatives. Yeah, and of course, if you are very new technology, innovative technologies, and I think in most of the suppliers or technology suppliers in Hong Kong, then there would be some concessionary offers on proof of concept projects. Yeah, and that's the way to kick the ball running in Hong Kong. Yeah, I think there are two major measures that we can take advantage of in order to penetrate the buy-in of the innovative technologies for energy management.
Thank you very much. So really hope to exchange ideas with you further in the future. So may I know whether there's any further question from the, from other participants?
Yeah, please feel free to ask. Yeah. No, I still have time actually. Yeah, my meeting is at 3, so I can still have time to answer questions if you have. I love sharing with students, and
that is the problem of having it online. So having it online, we cannot ping pong, we cannot cold call.
Yeah, yes, cold call. Yeah. And actually, yes, you are right. If it is an in-person on-site seminar, then I enjoy it more. If I have an opportunity when the COVID is gone and come to your campus to do this webinar seminar, then it would be much better. Yeah, more interactions actually. Yeah, I love this.
So any question from participants?
Oh, Kevin, one of the participants actually asked if you mind sharing the PowerPoint deck with us after the seminar.
Yeah, that's okay, no problem at all. And you said I will share the PowerPoint with you, and you'll post it on the website or what?
Yeah, later on.
Not right. Okay.
Yeah.
Okay, no problem at all. Yeah, just to share my PowerPoint, and that's all knowledge. Yeah, all
Thank
knowledge.
You.
Yeah, no problem at all. And let me see.
Michelle also got another question.
Michelle.
Yeah.
Any particular applications or technologies that could help create synergies between buildings of different users? Let me try to understand Michelle's question. Share application technology could help create synergies between buildings of different users. You mean buildings of different users, maybe the hospitals, or with it is one use, office building is another use, and data center is another use. Okay, if you ask me, okay, from the perspective of Schneider Electric, then we have one advisor, it's called a resource advisor, it's for sustainability actually. It's like a centralized platform to monitor buildings of different types. If you are a group, like enterprise, conglomerates, you have different buildings like hospitals, data centers, office buildings, and residential buildings. And you install the sensors, and then you can, of course, absorb the data and send it to the centralized platform, and the platform, I mean the resource advisor, the analytics, they will do the analysis for you, no matter it's on your energy consumption or carbon emissions. Then the management people, like the headquarters of sustainability, then they can really figure out what you should do to further the sustainability. And that's the one thing. Okay, I could say yes. For example, a data center locating beside a smart office. Okay, you mean how they communicate, or a smart office? Well, a smart office in a data center beside a data center locating beside a smart office. So how they can communicate? Okay, you can use the what you mean. Maybe I try to understand in this way. There's your smart office to control or to control the operation of the data center, right? Yeah. Is this something that you know? You want to know? as I said before, right now the buildings, because of the cloud computing and also IoT, and then you can really control or operate 70% of the functions of a building remotely, no matter what kind of buildings, like no matter it's data centers or hospitals. And that's the power, the magic of the data of the cloud and IoT technologies that we have. Yeah. So not sure whether I could answer your questions, Michelle. Okay, yeah, thanks. Okay, see whether you guys have any more questions. Yeah, feel free to ask. Helen, I would like to know whether the 4 advisors are sharing information with each other. Yeah, on cloud level, it is. Yeah. In terms of technology, what I mean is technology, yes, it is. Yeah, it is no problem at all. It can share the information, the data on cloud level. Yeah, more practical for Helen for this one. Yeah, maybe Helen is considering.
I think what comes down to is how to use the data. So I think the data is
exactly.
there, but how to use the data. So that's why I like
how to use
a triangle. Yeah, from data to information, and then all the way to wisdom, so that we can do something predictive, etc. So that's I think the IoT-based meaning is data-driven.
Yes, it's data-driven. How you use, that's why we have the analytics, the level 3, how we can draw out insight, or we call it, or people, if you want a better word, fancy word is called wisdom. How we can draw in wisdom, okay? Draw the wisdom out of the data. As you can see from the human civilization, we have a lot of data in the past, and then the human beings are more and more skillful in drawing the wisdom out of the data. Yeah, the world exists with data, but how we can make better use of the data to have some meaning, and how we can make our place better. And that's the evolution of human beings, not just the technology.
That's right. Yeah. Okay, so there's one more. The last question.
Carly, are the special technology to apply for Kelvin's developments in Hong Kong? Wow, it's a very, I think you're from consulting. Yeah, okay. Kelvin's is you want to build in the water plants or in yes, we have. Okay, we will. I would try, because it's very specific. It's more related to industrial things, industrial plants. And of course, we have some technologies, not just the IoT things. And I can answer you. Okay, you can leave the context. One thing that we talk more about is the asset advisors, because you have in the Kelvin's, for example, if you build a power water plants in Kelvin's, and you have a lot of pumps or you have a lot of motors, then we really need to monitor the power supply or the performance of those critical assets, and that's the thing that you can consider. And if your Kelvin's can be for the other users, like maybe railway or stations, MTR stations, and of course we'll have different kind of things. So what we need to see, what is the Kelvin's used for, and for the developments, because you will not live in the Kelvin's, there must be something that you want to make use of the Kelvin's, maybe a water plant, or maybe a train station, or maybe other things. So underground shopping mall, for example, and different usages. Then we'll have different technologies that can be applied for.
Okay, very well. So yeah, due to the interest of time, then probably let's stop here. Thanks very much for your very insightful and rich presentation. And I hope that you next time after COVID-19, then you really can come back and come to Hong Kong University and deliver another exciting presentation to us.
Yeah, absolutely. Yeah, it's always my pleasure to share more. Yeah, thank you very much.
Okay, so there's a promotion by Vivian, right?
Yeah, thank you, Jack. So
Okay.
next month in our Friday seminar, we'll invite Professor Gary Chen to talk about how localization technologies are applied to benefit our community. So welcome everyone to join us. We'll have the promotion very soon, so stay tuned.
Okay,
Thank you, Jack
so
thanks,
Kelvin, once again. May we have big hands to Kelvin. Okay.
Okay,
so
thank you. Thanks a lot.
Okay, so wish everyone good afternoon and have a nice weekend.
Yeah.
Okay, thank you.
Yeah, good Friday and nice weekend to all.
Bye-bye.
Okay, bye-bye.